Once the setup is ready, we'll see this screen. You can copy this link, click on Advanced, proceed to the link, and the reason this is happening is because we're using self-signed certificate and your browser doesn't recognize it. We will copy paste user credentials. Username is user, and then we just paste the password. Now we entered the Kubeflow tool we mentioned. To create the Python notebook and to run our code, we can click on Notebook, add new notebook, give a name for our notebook. And we can leave everything as it is and click on Launch. It would take some time until the notebook is ready. Now we will proceed to the next chapter. So here a brief explanation of what Kubeflow pipelines are. You can look through them. The first sample would be just creating a very simple pipeline just to understand what is happening. We'll simply create some pipeline where we will have two nodes that would add numbers given, and then there will be third node which will accept as a input previous two nodes. It would calculate their sum and echo it. Okay, to create this pipeline, what we'll do is first we would just copy the links, copy the code. Now our Kubeflow notebook is ready. We'll click on the notebook. Sometimes it doesn't load. You have to either wait or just restart the page. Okay, this is what we were supposed to see. And keep waiting or clear the workspace. Both should work. So it didn't work from the first tries, and I clicked on connect again, and then it connected. So this is a Jupyter notebook. Perhaps you have used it previously. We will create a new notebook, Python. paste it, run the code. We will just copy paste all the code. And what this code does, it creates Python function to wrap our component. This one would install the needed dependencies. You need to run it just once. And we can comment it. Let's run the code. So these are just simple Python functions. The first one adds two numbers. Second one echo just prints out. We would call it echo. And here is the explanation of the code. Then we will turn that Python code. We will use this Python code to create a pipeline. And to do that, we'll just copy the following code. We are giving the name for the pipeline, that's calculate some pipeline. We are giving description, and here is the pipeline itself. As an input, we would give A, B, C, D, and those A, B, C, D are passed to the functions that we mentioned. But now those functions would return us containers. Interestingly, in Python, if you just run this code, and the function is just an ordinary function without multi-threading. So yeah, if you run in Python this code, it would execute sequentially, like one by one. First, we would Python would calculate or perform this function. It would wait until it finished, and then it would do the second one, and then third one. But here, Kubeflow allows us to do things parallelly, to do everything that is possible to do in parallel. Okay. The first time it gives some unexpected error which disappeared. I just run it again. So yeah, it created a zip file. The content, we won't be able to open it here, but the content of that zip file is YAML file. YAML file is used to create Kubernetes pods. So yeah, the content looks like this. Now we would basically what it created, it just described the project that we created. And now we'll use that description to actually compile and run. So here we can click on experiment details. I'll just go with run details. So like I said previously, that the function would Kubeflow allows us to run two different tasks at the same time, if that's possible. So in our case, calculating sums, adding the first two numbers, this block of code would calculate add A plus B, and the second one would add C plus D. And they don't depend on each other, hence they could be performed parallelly. And the output of these two functions So the first function gives us 17, second gives us 11, and those 11 and 17 are passed to our third function, third block, third component. 11 and 17, we added 28, and we pass this 28 to our echo container, and it would output the sum. It would echo the sum. This is just a simple pipeline. Its objective was to show the basic steps of creating pipeline, creating containers within pipeline. Now we would go with more complex pipeline, and that is what we will do in real life. Okay, so here the task is to create a smart scheduler using some data, previous data. You can read through, but what we're trying is we would train two models giving the same data, and then depending on which model performs better, we choose the best one and use it for our schedule generator, smart scheduling app. The same way here, we are defining some functions in ML pipelines. We have data pre-processing, feature selection, splitting the data into training, testing sets. Then we have train test classifier nodes, and eventually we would pass the best performing model to our smart scheduling container component. So you can just one by one copy the codes. And it would do everything for us. Let's rename the first one. So we have here we are importing components that are needed. Okay, it looks like there are certain libraries that we didn't install. So apparently we needed to update KFP, and that is done through this command, which is provided in the tutorial. So it would download everything that we need. Once it's complete, we can just comment it out. Yeah, now when we run it, it won't. It still has those old components. Let's try to restart it. So yeah, now it works. So what happened here is that we had old KFP, then we updated that KFP, but the kernel, we needed to restart the kernel. So we can just copy paste all the code, and eventually we should have all the code over here. Then we would execute everything one by one. Then we have run experiment, experiment details, run details. If you click on experiment details, it would just show you the status of experiment. It's still running, not completed. Once it's completed, it would show you duration and more details. Now we can click on run experiment and it would take us to a window. So here we can see our pipeline being built. It would take some time until it's complete. Now our pipeline is ready, and we can see that there are several containers performing their task. The first one is pre-process and select feature, and cool stuff about Kubeflow is these two components that are being executed parallelly, and so we are training. We have the data, we are pre-processing data, we are selecting important features and dividing the data, splitting it, and then we are training the same data with different classifiers at the same time. In this tutorial, we have just two classifiers, and you can train with as many as you want. And once those training is over, classifier is being tested, and their performance is being evaluated. You can see that the first classifier has 0.92, the second one has 0.9 accuracy, and then the best classifier is chosen. So apparently the best classifier here is random forest classifier, and here we can see the importance of features in a descending order, and eventually that classifier is being passed to a scheduling component that takes data from pre-processed data with needed classifier is passed, and we can see that smart scheduling is performed. So this is the end of the lab. Do not forget to remove all the virtual machines you created everything that you created. And to do that, you need to go to AWS console, instances. Alternatively, you can type here EC2, EC2, click on EC2 instances. We see our Kubeflow. Then we click on terminate instance. That's it. Thank you for your attention.